Hello children, welcome to Graphing Polynomials in Factored Form. Alright, so here's a polynomial written out in standard form. It's cubic, and we're going to factor it. This one's easy to factor. We have a GCF of 2x, and then we've got x squared plus 6x plus 9. And then that factors, so we've got 2x, and then we have x plus 3 and x plus 3. Or, as we should write it, f of x equals 2x and x plus 3 all squared. Okay, so we factored it. Now we're going to graph it from this form. And you can't see that very well, can you? I'll get off this color. Okay, so here's our factored or intercept form polynomial. We can call it factored form, we can call it intercept form. It all means the same thing. But when you have it in factored form, the first thing that you can find, the quickest thing you can find, are your zeros. And just like we've done before in the past, if I set each factor, equal to 0, then I should be able to find all the zeros of this function. So if I set 2x equal to 0, I get x equals 0. Still can't see this color either. My goodness. Let's just change it to bright yellow. And if I set that factor equal to 0, I get x equals -3. And there's something special about this one. Because it's squared, it's actually in there twice. So we say that this 0, -3, has a multiplicity of 2. Multiplicity is what we use to talk about when things repeat, when our zeros repeat. So we have a multiplicity of 2 for the 0x equals -3. The 0x equals 0 has just a plain old multiplicity of 1. It's in there one time. So what does that mean when we graph? Well, think about what it meant when you had a parabola. It meant that your parabola bounced on the x-axis instead of crossing through it. So let's define let's not define multiplicity, but let's write a note for ourselves about multiplicity. And that is, if your multiplicity is odd, so like this one, or if it was to the third power or the fifth power or any other odd power, then the graph crosses the x-axis at that 0. And if the multiplicity is an even, like this one, then our graph is going to bounce on the x-axis. So when I go to graph this one, I know that I'm going to cross through the x-axis at x equals 0, and I know I'm going to bounce on the x-axis at x equals -3. So now let's talk about some other things we know. I just copied down my information again. You don't have to do that. But we know where the zeros are. We also know about end behavior, because we learned the other day that if it has a positive leading coefficient, which this one does, our leading coefficient is 2, then it is going to go up on the right. And we know that if it has an odd power, this is a cubic. I know you see this too here and you jump to conclusions, but remember before we factored it, it was cubic. This x in here gives us another one. So it's an odd degree, which means opposite, so it's going to go down on the left. We also know that a cubic has a maximum of 2 turns. So we can't just start drawing crazy willy-nilly turns wherever we want to. So I've just shrunk my writing, added some graph paper. Let's go ahead and graph this. I know that the zeros are going to be, we need an x-axis. And I know the zeros are at 0 and -3. There's my y-axis. So we have a 0 here, where I know we're going to cross through, and we have a 0 here, where I know I'm going to bounce. I know it's going up on the right, so I'm going to draw a little arrow out of the right, up. I know it's going down on the left. I'm going to draw a little arrow out of the left, down. How do I know it doesn't turn and come back? Because it doesn't cross the x-axis again. And then I need to know what's going on in between here. Well, I know this is a bounce, so I know it's got to be going back down this way, and this is crossing through. So I just now need to figure out how far down does that go. So now I can just plug in x values. So I'm going to plug in a -1. If I plug in a -1, I'm going to get -8. So I have a point down here. And I'll plug in -2 as well. So if I plug in -2, I am going to get -4. So that point goes right there. And it could dip a little further down than this. Probably does, just a little bit. But those are good guidelines. We're just sketching the graph. And so now you ask, well, how do I know it doesn't do other weird things in between there? Because there's one turn and there's the other turn, and we can only have 2. We've used them up, so it can't turn anymore. We knew for sure we were going to have one here because we knew we were going to have a bounce. So there has to be only one left in between, and we've kind of found where it is. It doesn't have to be perfect right now because you're not using a calculator, and I'm not going to expect you to plug in all the fractions and stuff. So that's it. That's how you graph in factored form without a calculator. All right, before we quit, I want you to try another. So here's a bigger one, but it's already factored for you. Don't worry, we'll learn how to factor the big ones ourselves later. But right now, here's the big one factored for you. First thing we want to do are find the zeros, and those are at x equals 0 for this one, 5 for this one, right? 2 for this one, and -3 for this one twice. So I'm going to write bounce. If we were asked what the multiplicities were, you could tell me that these 3 have a multiplicity of 1. This one has a multiplicity of 2. All right, what else do we know? We know that the leading coefficient, if I were to multiply this all out, I'd have x and x and x and -x. So my leading coefficient is -1. That means it's going down on the right. My power, we got to count how many x's we're going to have here. We got 1, 2, 3, and then 4, 5. So my degree is 5, which is odd. Odd means opposite, and the opposite of down would be up on the left. Another thing that I know is if this is 5th degree, it's going to have at most 4 turns. It could have less than that, but at most 4 turns. Sorry, I can't spell. All right, so all those things that I know about it, I'm going to plot the graph now. I'm going to do my best. All right, so our zeros are at 0 and 5 and 2 and a bounce at -3. I know it's going down on the right. I know it's going up on the left. I know that there's a bounce at -3, so that'll go like this. We know that it is going to turn at most 4 times, and we've taken 1 already. So we can only have 3 more. That means that between here and here and here, it's going to have to turn 1 time in each interval. So we don't have any weird other stuff going on. So now all we have to do is figure out how high and how low does it go. Because I know it's going to go up and cross down through here. It's going to go down somewhere and cross back up through here, and then it's going to come down. So if we plug in a -2 for x, for y we will get, and I'll save you the time, and I'll just tell you that you get 56. So that's pretty high. So I'm not going to draw it on there yet because I don't know how high or low this really is going to go. I'm going to plug a -1 in for x. I'm going to get a 72. That's even higher. And then at 0, we're back at 0. So it's going up really high. Let's plug in a 1. If I plug a 1 into the function for all the x's, I get negative 64. If I plug in a 2, 2 is 0, sorry, if I plug in a 3 into all of this, we're going to end up getting 216. And if I plug in a 4, I'm going to get 392. It's a tall, tall graph. And then at 5, it's jumping right back down to 0. So I'm going to have to count my increments in, let's see if 20s will work. Nope, we got to use 50s. 50, 100. See, I'm doing it wrong again. Hold on. All right, 50, 100, 150, 200, 250, 300, 350, 400. And I'm probably writing my scale right where my graph wants to go. But let's plot these. If we went by negative 50s, there's negative 100. We're actually not going to go down that low, so let's put the graph on there. For negative 2, we were going to 56. For negative 1, we were going to about 72, so it curves about like that. For 1, it was at negative 64, about there. And then I guess it just curves right back up. At 3, we're at 216, so way up here. 4, we're at 392, almost 400, and then we'll just come back down. So that's approximately what it looks like. We don't know the exact maxes and mins, and that's okay. We'll figure out how to do those later. Right now we're just sketching the graph, knowing our end behavior, our turns, and our zeros. Okay guys, and since this is the last video that you're going to watch before Thanksgiving, here you go. Happy Thanksgiving. I know I'm going to have a good break, and I hope you all do too. Bye.